Hello grade 9s, this is the first video of your first lesson of chemistry for 2020. So I know you did SI units and proportion in the first term. That was neither really chemistry nor physics, it was a little bit of both. And then the other topics that you've done haven't really been chemistry as such, so electricity and force, work, energy, power, that falls under the category physics. But in science, physical science, we do chemistry and physics, and now you're going to start with proper chemistry for grade 9s. So this first lesson is largely just a revision of grade 8. I have uploaded the grade 8 notes memo for you in case you have lost your grade 8 notes or forgotten anything from there, because they're quite useful to refer back to. So the definitions that you'll see now are the same or similar to the grade 8 ones. You do need to know definitions, as you should know by now. So what I recommend you do, get some postcard sized cardboard and write down the definitions from the very beginning of the year up until today. And that will allow you to have a box of your definitions cards ready to study at the end of the year when you have to write an exam on all of the definitions through grade 9. And the same applies for grade 10 and 11. Each year, start out and from the very first lesson, whatever definitions you get, write it on a piece of colored cardboard and keep it in a small box, so that at the end of the year you've got one box with all the definitions that you need to know. So we're going to start with a periodic table. Before we do that though, some definitions. An atom is the smallest particle of an element that can exist. And a little bit of revision for you, there's the structure of an atom. Again, you did it in grade 8, so you've got the nucleus in the center. Inside the nucleus are positive protons, maybe put a little plus sign there, negative neutrons, and negative electrons, and the neutrons I'll do in green because they are neutral. Maybe we'll do them in black. Black wouldn't be neutral, otherwise green you might think is a negative. Okay, so neutrons have got no charge, protons are positively charged, electrons are negatively charged. And electrons are much smaller and lighter than protons and neutrons, and they're found around the outside of an atom. Okay, so that's the structure of the atom. An element is a pure substance which consists of only one kind of atom. Only one kind of atom that cannot be broken down into anything simply by physical or chemical means. Cannot be broken down. It cannot be broken down into anything simply by physical or chemical means. Right, so elements are what you would find on a periodic table. A compound, we're going to get to that definition in a minute. But yeah, if it's an element, you must be able to find that element on the periodic table of the elements. So if you want to write on the top here, the periodic table of the elements. Remember, it's periodic table of the elements, not periodic table of the compounds, guys. Okay, so a pure substance is a substance that consists of one type of particle only. One type of particle only. Whereas a compound is a substance that's formed when you have two or more different elements that are chemically bonded together. That are chemically bonded together. This is in contrast to a mixture. You don't have the definition of a mixture here, but a mixture is just a mixture of two substances. Those substances can be elements or compounds. So over here, a mixture can be two or more elements or compounds that can be separated by physical means. Okay, so this you would have done last year. So say for example, if I had a box of Astros and a box of Smarties, and I poured them into one bowl and I gave it to you and I said, is this an element, a compound, or a mixture? You should tell me that it's a mixture. A mixture of what? A mixture of Astros and Smarties. And physical means, there are some different physical means. You can have magnetism, you can have filtration, you can have magnetism, filtration. Another one is hand separation. Okay, those are just some examples of physical means. So if I gave you the box of Astros and Smarties and I said, okay, go separate them, you would be able to hand separate them. It would take a little while, but you could pick out the Astros and put them into a bowl, and you could pick out the Smarties and you could put them into another bowl, and you have then separated the mixture of Astros and Smarties. So those are examples, like I said, of physical means of separation. Remember I told you that a compound is something that's that is formed when two elements are chemically bonded together. So if I melted the Astros and the Smarties, that's then a chemical reaction that's taking place, and you wouldn't be able to separate them. Also, an element is a substance that cannot be broken down into something simpler by either physical or chemical means. So those physical means is what I just spoke to you about now, the hand sorting, separating by magnetism. The example for that is last year you would have dealt with iron sulfide. So iron is magnetic, sulfur is not. So if you have a mixture just of iron and sulfur together, you could use a magnet, and the magnet would pull out the iron particles and leave the sulfur behind, right? Whereas if you heat it, which you did the practical for that last year, and you made iron sulfide, that compound you were not able to separate by physical means. You couldn't pick out the iron particles alone using a magnet. Okay, so that was a compound that was formed when you made iron sulfide. So we've got hand sorting, magnetism, and another one could be filtration. So say, for example, you had a mixture of sand and water. You would have been able to separate out the sand and water by filtering out the sand. One last one is distillation, okay, or evaporation. So please make sure you make a note of the different ways that you can separate a substance physically. So distillation is where you boil a mixture of two different liquids. The one with a lower boiling point would start boiling first. Or evaporation, if you had a mixture, say, of salt and water, you could heat it, the water would evaporate off, and you'd just be left with just the salt behind. So no chemical reaction took place there. Okay, a compound is a substance formed when two or more different elements are chemically bonded together. A molecule is a group of atoms that are held in a fixed ratio by strong forces called chemical bonds. The atoms could be the same type or different in a molecule. A little typical example of this, the formula for water is H2O. But another substance, H2O2, is hydrogen peroxide. So for water, for every one oxygen, you've got two hydrogens, whereas for hydrogen peroxide, for every two oxygens, you've got two hydrogens. So there's a 1-to-1 oxygen to hydrogen ratio for hydrogen peroxide, and a 1:2 ratio for water. So that's what I'm talking about when I say fixed ratio. All right, and then a crystal lattice is the symmetrical, three-dimensional, I'm just going to write 3D, three-dimensional arrangement of atoms inside a solid. And symmetrical means that refers to mirror or reflective symmetry. So you can draw a line if you're talking about 2 dimensions, or a plane in 3 dimensions through an object so that the two halves are mirror images of each other. So for example, your left and right hand are mirror images of each other, so we say that they are symmetrical. This diagram is quite important, so let's go through it. So the first three, so diagram A, diagram B, and diagram C, those are all pure substances. And we said that a pure substance consists of only one type of particle, right? So here we've only got red particles, here we've only got purple particles, and here we've only got a molecule that's got 1 purple and 3 greens. This one has got 1 purple, 3 greens, 1 purple, 3 greens, 1 purple, 3 greens. So it's still the same type of particle, right? The fact that this one has got 2 different atoms in it, green ones and purple ones, we're not talking about that. It's only each molecule is 1 purple and 3 greens. Okay, so an element, pure substance, only one kind of atom, so within the element we've only got red atoms. Here is a molecule, and this molecule is, those are molecules of an element. So again, we've only got purple atoms inside there, but they are bonded together. Okay, so a molecule is a group of atoms held in a fixed ratio by strong forces called chemical bonds. So between each of those purple atoms there is a chemical bond. So you cannot separate those two purple atoms by physical means. They're chemically bonded together. So that's an important thing to understand with that. So the molecules of an element versus molecules of a compound. Molecules of an element, only one type of atom. Whereas over here we've got molecules of a compound and you've got two atoms, purple and green. And that's the difference between the molecules of the element versus molecules of a compound. Alright, now I've got a mixture of elements and a compound. So what I'm circling in red, the red atoms, those are atoms of an element. What I'm going to circle in blue, those are molecules of an element, because they both consist of the same element, purple atoms. Okay, and what I'm going to circle in yellow, those are molecules of a compound. Compound because there's two or more elements and they're chemically bonded. So between the purple and the green, the purple and the green, and the purple and the green, those are all chemical bonds. Alright. Okay, so now I've got the periodic table. Those of you who weren't able to print notes, if you don't have a printer to print these notes, what you can do is get a test from last year. We would have given you a periodic table at the back of your test. Your final exam last year would have had a periodic table, so get that, and that will, you can use that to write on for this exercise. Right, so some things to remember from last year. We talk about periods and rows. Right. So periods go across. So if you want to write that going this way, let's do it in blue. Period goes from left to right in the periodic table, whereas a group goes up and down. In fact, that's fine. So this is group 1, this is group 2. This is period 1, this is period 2. So group up and down, and periods go across. Okay, so this is period 1 across there, this is period 2, period 3, period 4, period 5, period 6, period 7. And if I talk about groups, group 2, group 1, group 3, group 4, all the way up to group 18. You may see some books that do this slightly differently, and the older convention is to use Roman numerals. So if you use Roman numerals, then you've only got 8 groups because we skip what we call the inner transition metals. So in Roman numeral form, you might see this. Group 1, group 2. You skip what we call the transition metals, and this then becomes group 3, group 4. You can Google how Roman numerals work if you don't know this. Group 5, group 6, group 7, and this is group 8. Okay, so if you do it in Roman numerals, you ignore what we call the transition metals. Alright, so let's talk. Element symbols. Because we need to know the names of elements, so often we use symbols instead of writing out the whole word, because it's much quicker to write out a 1 or 2 or 3 letter symbol. The symbol of an element consists of only 1, 2 or 3 letters, but there are some rules. So the first letter must be a capital. Okay. The second and third letter, if there are a second and third letter, are lowercase. So first letter is capital, second and third are lowercase. You'll find some letters on the periodic table have only got 1 letter. For example, hydrogen and potassium have only got 1. Some have actually got 3. So for example, if you have a look, some of the transition metals will have 3 letters. So if we give you a question in a test to name a fictitious, magical, mystery, new element that's discovered, give it a name, if 3 letters or 2 or 1, but the first letter must be a capital. And also, if we ask you to name something that's a newly discovered element, you cannot go and give it a name of something that's already on the periodic table. So if I decide that there's an element called chocolate or chocolaterium, and I said give it a symbol, you cannot use calcium because that's already on the periodic table. You cannot use Ca, sorry, you can't use Ca, you can't use Co, because those are symbols that are already on the periodic table. So you can't just use C either, because that's already the symbol for carbon. Ca is the symbol for calcium, Co is the symbol for cobalt. So you need to have a look on the periodic table and make sure that what you choose is not already a symbol that's on the periodic table. You need to come up with something new. And like I said, notice how the first letter of all of these is a capital. Okay. On your periodic table, we're going to complete this exercise. So match the group names to the correct group number. Noble gases is group 8. Alkali metals is group 1. Alkaline earth metals, let's write these down for you. So that's group 8, or in Roman numerals, or in terms of the 1 to 18 system that's on your periodic table, that'll be group 18. Alkali metals is group 1. Alkaline earth metals is group 2. Transition metals is group 3 to 12. And the halogens is group 17. Okay. Draw a line on your table to separate the metals from the non-metals. This was the staircase that you learned about last year. And use green to highlight the magnetic elements. Okay. Then I need you to use a yellow pen or highlighter to color in elements that are liquids at room temperature. There are only 2 of those. They are mercury and bromine. Symbol for mercury is Hg and bromine is Br. And then use a red pen, and let's get the yellow highlighter, red pen or highlighter to color in elements that are gases at room temperature. Okay, for those, nitrogen, oxygen, fluorine, chlorine, bromine is a liquid, and then all of the group 18 gases, which are actually called the noble gases. Alright, so let's do this together. In fact, I recommend you pause the video, do it yourself, but if you're not sure, then I will help you. Okay, so group 1, alkali metals. Group 2, alkaline. Please be careful, there's a difference. Alkali versus alkaline, they're not the same. Please don't mess that up in tests and exams. Okay, alkali versus alkaline. Please don't get confused between those two. Highlight it or underline it or make a note so that you don't get confused. Group 1 is alkali metals, group 2 is alkaline earth metals. And as the name suggests, guys, alkali metals and alkaline earth metals, they are metals. Alright, group 3 to group 12. So what's highlighted or what's bracketed over here, that we call the transition metals. So what's in what I've just circled in a red box or drawn a red box around, those are the transition metals. You'll notice that there is a number. The number in the top left is the atomic number, and that means how many protons we've got. So that's the proton number for atomic number. And relative atomic mass, that's what's on the bottom here. Relative atomic mass is protons and neutrons added together. Okay. So you'll notice that we go from hydrogen with an atomic number of 1, and then you go across to helium with an atomic number of 2, and then we go 3, 4 for lithium and beryllium, 5, 6, 7, 8, 9, 10, and so on. Then we get to 54 for xenon, 55 for cesium, 56 for barium, and then between 56 and 72 there's a gap, and what that actually means is that there's an extra block, and we call that the inner transition metals. So this block over here is called the inner transition metals. Okay, so 57 all the way up to 71 are in the top row. Then we go across to 86 for radon, 87 for francium, 88, and then we go 89 onwards up until 103. Okay, so please make a little note to that. Then the halogens are group 17, and group 18 is called the noble gases. Guys, noble gases are gases at room temperature. Right, so we have to match up the group names. We've done that. Then draw a line on your periodic table to separate the metals from the non-metals. Let's do that in blue. So that was the staircase that you learnt about last year. And to the left of it is metals. To the right of the staircase, we've got non-metals. Okay. Then number 3, we had to use a green pen or highlighter to colour in the magnetic elements. There are only 3 of those. You should remember that from last year too. They are iron, cobalt and nickel. That's not green. Okay, so iron, cobalt and nickel are magnetic. Just those 3 are magnetic. And then we had to use a yellow pen or highlighter to colour in the elements that are liquids at room temperature. So I told you there were only 2 for that. Mercury. And the other one is bromine. Bromine is a halogen. Okay, so those were the liquids. Liquids at, I'm just abbreviating, please don't use RT for room temperature in tests and exams, rewrite the whole thing. They're liquids at room temperature. Then use a pen, a red pen, or highlighter to colour in the elements that are gases at room temperature. Okay, so I already gave you a hint with that. The noble gases are gases. So the group 18 gases, noble gases, they're gases. Nitrogen makes up 78% of air. Nitrogen is a gas. Oxygen, 21% of air is a gas. And fluorine and chlorine at room temperature are gases. Fluorine gas and chlorine gas. Okay, so those are the gases at room temperature. Then we've got diatomic molecules. Diatomic molecules are molecules that consist of 2 atoms. Most diatomic molecules are of the same element, though a few combine different elements. So you need to use a pink or red highlighter or pen to colour in the diatomic molecules. Let's do that with pink. There's a little acronym that I'd like you to remember, which is have no fear of ice cold beer. H stands for hydrogen, N for nitrogen, F for fluorine. I'm actually just going to use the chemical symbols because you should start to learn the chemical symbols. So hydrogen is just H, nitrogen is just N. Then we've got fluorine, which is just F. Oxygen is just O. I is for iodine, just I. C should actually be Cl because it's chlorine. And Br is for bromine. But the acronym, to remember it, have no fear of ice cold beer, and those are the diatomic elements. So it can help you to remember that. So on your periodic table, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and let's also show hydrogen. So those are diatomic elements. If that gets a bit messy, it might be perhaps be a better idea for you to just go put a capital D in each of those. D for diatomic. So what that means is that you've got two elements and they're bonded together to form a molecule. Okay, this activity I would like you to please do with a friend. So obviously normally we do it face to face in class, but it's fine, you can still do it with a friend. If you don't have a post-it, then just lick a piece of paper and stick it on your forehead, and then your homework will be to do the test your knowledge. Test your knowledge starts here on page 4 and continues onto page 6. Okay, so up to and including define the term atom. So everything above that, that's going to be your homework. It needs to be done by the next lesson. Your teacher will ask you to submit it or to randomly check to show evidence that you have done it. You should be able to finish it in the rest of this lesson. And this is just a fun activity, like I said, for you to do. Please do that in conjunction with a friend. Also part of your homework will be to please make sure that you learn these elements that are in this box, these two boxes. The names and the symbols you have to know, otherwise you will not be able to do chemistry. So please, that's also part of your homework, is to remember those. Be very careful, some are very similar. So for example, S is for sulfur, whereas, what's another example? There's some weird ones as well, like Sn is tin. Don't just think that any element that starts with a C has got the symbol C. So we've got carbon with a C, cobalt, calcium, copper, all of them have start with a C, but the symbols is obviously not just C for all of them. Please make a note, sodium is Na, sulfur is S. Please don't use sulfur for sodium, because some people do that and that's just weird. Okay, thank you very much, grade 9s. I hope you enjoyed learning some more about the chemistry from last year. Please let us know if you've got questions. Thanks, bye.